Okay, well, this week we're going to start with rational exponents and radical notation. Now, where do rational exponents come from? Let's look at one of those examples again. You don't have to write this down. Let's start with 2 to the 8th. Not even sure what that is. I have to put that in my calculator. 256. And I'm going to half the exponents each time. So 2 to the 4th, 8 divided by 2 would be 2 to the 4th. And that is 16. Half that again, we'd have 2 squared is 4. Half that again, we'd have 2 to the 1, which is 0. Half that again, and we have 2 to the 1/2. So let's see what's going on over here on the right. So to get from here to here and here to here doing the same thing, you actually wouldn't, and I see where I made a mistake here. 2 to the 1 is 2. Sorry about that. You actually wouldn't add or subtract. If you take the square root of 256, you get 16. If you take the square root of 16, you get 4. If you take the square root of 4, you get 2. If you take the square root of 2, you get the square root of 2. So this is why 2 to the 1/2 is the same as the square root of 2. If we divide it again, we'd have 2 to the 1/4, and that would be the square root of the square root of 2, or the 4th root of 2. Again, would be the 8th root of 2, and so far. So that's kind of an idea of why the roots turn into rational exponents. So let's look at an example here. I'm going to take this this root, it's the third root of 2a cubed b squared, and we're going to change it to an exponent, 1/3. So as a general rule, if you have the mth root of a to the n, that is a to the n divided by m. So whatever's going on under the root is whatever exponent is under the root goes on top, and the root itself goes on the bottom. Over here, so we're going to do 2 to the 1/3. We'll do a to the 3rd to the 1/3. So that's 3 times 1/3 is 3/3. And 2 times 1/3 is 2/3. Reduce that, and we'll have 2 to the 1/3. A to the 3/3 is just 1, and B to the 2/3. And that's where we'd stop if we're writing it in terms of exponents. What if we want to go the other direction? So here we have 5 is on the bottom, so that's the root. So it's the 5th root of 10xy to the 3rd power. And we can reduce this, 10 to the 3rd, x to the 3rd, y to the 3rd. It's the 5th root of all that. And go ahead and expand it. 10 to the 3rd is 1,000. Then we'd have x to the 3rd, y to the 3rd. And I better not forget my 5th root there. And I believe that's it for this first section.